All right, what we have here today in this video, we're going to talk about the cofunction and even and odd identities. Starting with the cofunction identities, I'll explain a little bit about those using the unit circle, give you an example, move on to the even and odd identities with an explanation and an example. The cofunction identities are these relationships that we have here that take us from the sine of pi minus 2 minus theta equaling cosine of that same theta. So this angle here is the same in both. If I take the cosine of the angle, that's the same as taking pi minus 2 of that angle, and we would take the sine at that point. It sounds confusing. You should jot all of these 6 down, but I'm going to do an explanation on the unit circle, so pause if you need to jot those down. So we're talking about complementary angles here. That means two angles that add up to 90 degrees, or pi over 2. The sine of one angle is the cosine of the other. So taking 60 degrees right here, or 30 degrees. The sine of 30 degrees is the cosine of 60 degrees, and vice versa. So the sine of 30 is the same thing as the cosine of 90 minus 30, or 60 degrees. If we're in radians, we would use pi over 2. This works for the other ones as well. So we're just talking about complementary angles. The sine of one is the cosine of the other. Tangent of one is the cotangent of the other. So some examples with cofunctions. I'll walk through the first one, and then I'll just leave my answers for the other two. So first thing I'm going to look at, I have pi over 2 minus x, cosine of pi over 2 minus x. This becomes sine of x. And then I have cosecant x times sine of x. Those two are reciprocals of each other. So if I multiply two reciprocals by each other, I should get 1 as my final answer. I'm going to pause and put up my answers to the other two so you can check yours. There's the second example. And the third example. I could cross out one of the sines and one of the cosines. Cosine x over sine x leaves me with cotangent x. The even and odd identities, again, pause, jot these all down. Again, it looks overwhelming to just see it all written out, so I'm going to go through an explanation with both the graphs and the unit circle. So pause if you need to jot this down. So this comes from the idea of even and odd functions graphically. An odd function has rotational symmetry around the origin, and an even function has reflectional symmetry over the y-axis. We can also see this on the unit circle. If I look at, let's take 60 degrees here. The sine of 60 degrees is root 3 over 2. If I go down to negative 60 degrees, then that same sine value also became negative. If I were to look at the cosine, grabbing another color here. If I were looking at cosine, root 3 over 2, it's still positive root 3 over 2. So moving back a page real quick, if you take the negative angle in sine, you get the negative version of the sine value. If you take the negative angle of cosine, you do not get the negative. So we have odd, these are odd, and even. I will walk through the first example, and then I'll put up my answers for the other two. Cosine of negative x. Well, since cosine is even if I take the negative value, it's not going to change, so I still have cosine of x times the secant of x. Those two are reciprocal, so I get 1 as my answer. And I'm going to pause and put up my answers to the other two. Sine of negative x becomes a negative sine of x. Cosecant and sine of x are reciprocals, but I have the negative here, so I get negative 1. And on the last one, both of these are odd, so they both became the negative versions of themselves. I have a negative times a negative, so I get a positive, and tangent and cotangent are reciprocal, so I get 1. That's it. We'll have a short homework quiz on this topic.